Hello everyone. Physics is never a difficult subject for a student who is interested, provided he or she has a clear and strong physics teacher. So here I am, Mr. Dharanidhar, your favorite physics teacher in your favorite YouTube channel, Bhautics. So today I have brought you one more question that was asked in the board examination. The same model question was also asked in the one more question paper which we have solved in the last classes. You can go through my YouTube channel playlist of PYQ light reflection on refraction to solve that question also. Same model was asked but the numbers was changed. So let us solve this question also. The question is an object is placed in front of a concave mirror of focal length 12 centimeters. If distance of object from pole of mirror is 8 centimeters, determine the image distance. So we have to find out the image distance. So which case it comes under? See, if we remember the concave mirror, how concave mirror will be here? Concave mirror will be like this. Correct? So like this. This is the center of curvature. Somewhere from here it is 6.3 centimeters, so 3.1 centimeters. This one will be the focus. This one will be center of curvature. This point will be pole, right? So what did they mention? They mentioned that the focal length of the concave mirror is 12 centimeters. Object distance is 8 centimeters only. Means the object did not even reach focus. Suppose from here to here 12 centimeters, then from here to midpoint it will be 6 centimeters. Object is placed at 8 centimeters, means object is placed somewhere here. So here object is placed. If the object is placed here, we have to find out the image distance. Okay. So now let us solve the question now. Using mirror formula only we are going to solve. Simple question only. Right? A simple question only we will solve using the mirror formula. So let us write out the given data. Given data, what all they have given, I will suggest all children to first identify what is given, mirror or lens. If it is mirror, which type of mirror? Which type of mirror is given here? It is given as concave mirror. So first write that concave mirror. Why sir? Why do we need to write this one? Why? Because if it is in case of a concave mirror, focal length will be negative. In case of a convex mirror, focal length will be positive. That's why first write concave mirror. So what is concave mirror? Focal length is negative. So now next, what they have given still? They have given focal length. Focal length is equal to minus 12 centimeters. Focal length is represented by f, and they also gave object distance. They gave object distance u is equal to minus 8 centimeters. See, object distance, object is placed here. We are moving towards negative x-axis from pole. So object distance is also negative. Focus is here. To measure focal length, we will move from pole towards negative x-axis. So focal length is also negative. So now what we have to find? We have to find out the image distance. Image distance is equal to question mark. So if you remember the ray diagrams of concave mirror, if the object is placed here, image will be formed on the other side of the mirror. Virtual, erect and magnified image will be formed. Correct? Somewhere here image will be formed like this. Correct? Remember the ray diagrams. That this is why we say ray diagrams are very important. Somewhere here image will be formed, virtual, erect and magnified. Like this image will be formed. This is object and this will be image. So if the image is formed on the right side of the mirror, we should get image distance as positive. Correct? So let us verify. If we get the image distance as positive, then it means that we have solved the problem perfectly. So let us use the mirror formula. Mirror formula is 1 by f is equal to 1 by v plus 1 by u. I suggest all children to remember mirror formula as 1 by f is equal to 1 by v plus 1 by u only. Not as 1 by f is equal to 1 by u plus 1 by v. Why? Because if you remember it as 1 by v plus 1 by u, if you change the polarity, lens formula will come. So that's why I suggest all children to remember mirror formula as 1 by f is equal to 1 by v plus 1 by u only. So next, substitute the values. Remember, while substituting the values into the mirror formula, which we know those should be given with polarity. Now we know that v will be positive, even though you should not give any polarity to v. V will come out with the polarity. Okay. So focal length. What is focal length polarity? It is given. It is minus 12 centimeters is equal to 1 by v we have to find out plus 1 by u is minus 8. Correct? Correct. So it will become as minus 1 by 12 is equal to 1 by v minus 1 by 8. So plus into minus minus. So this minus 1 by 8 I will send that side. It becomes plus 1 by 8 minus 1 by 12 is equal to 1 divided by v. Correct? So next step will be, I will send this 1 by v whole this side plus 1 by 8 minus 1 by 12 whole this side. It becomes 1 by v is equal to 1 by 8 minus 1 by 12. Correct? So next step, I will write here. So 1 by v will be is equal to LCM. 12 and 8. How much will be LCM? 12 and 8 LCM will be around 24. 8 3 is 24, 12 2 is 24. So 1 by 8 into 1 by 8 it will be 3. 1 by 12 it will be 2. So 1 by v is equal to 3 minus 2, 1 divided by 24. So v will be is equal to 24 centimeters. So we got positive. Understood or not? So write the last statement as image distance is plus 24 centimeters. After writing this, don't forget to underline such that you will get a good opinion in the paper corrector. Now they also asked you to draw the ray diagram to justify your answer. How shall we draw the ray diagram for this one? See. Right. Some students will ask, sir, they mentioned focal length is 12 centimeters. Shall we take focal length as 12 centimeters only? No, not required. Not required to draw the focal length as 12 centimeters only. We can take our own measurements and we can just mention that it is 12 centimeters. So the best measurement will be, first step is to take a straight line of 10 centimeters. Okay. And mark a point at 5 centimeters also. Mark this point as focus, this point as pole, this point as center of curvature. Now what shall we do? You take a compass, take a radius as 10 centimeters. Right. So take a radius as 10 centimeters and you draw an arc. See, don't take the lengthy arc. If you take a lengthy arc, what happens? Diagram will not look good. Just 4 to 5 centimeters. If you measure this one, this should be around 4 to 5 centimeters enough. See, exactly 5 centimeters it is. If you take that much only, then it will look good. Diagram will look good. And these lines, which small lines I am drawing now, these lines are very important. That represents that it is a mirror. If that is not given, then it will be working as a glass, not as a mirror. Okay. So now we have to take object between F and P. According to the given question, you see here, object is placed closer to focus. If the object is placed closer to focus, image distance is 24 centimeters. Focal length is itself 12 centimeters. 24 centimeters from pole means it is going approximately radius of curvature. Object distance is this much, image distance is this much towards the right. So that's why if we take object close to focus, what happens? Image will move far away from the pole. That's why you take object closer to pole. Sir, they mentioned to take closer to focus. No, their intention is to take object between focus and pole, not to take close to focus or close to pole. So you can take object closer to pole, mention this as object. So now take one light ray parallel to principal axis. Diagram should be very neat. The examiner should not find any mistake in the diagram. So one light ray parallel to principal axis. After reflection, how it should pass? It should pass through focus. Correct? So this point of incidence and this focus should be coinciding. Make sure your scale is like that. Then you draw the reflected light ray. So this is the reflected light ray. One more light ray we want. See, one more light ray we can take through center of curvature or through pole also. I'll take through center of curvature. We can take through center of curvature or through pole also. Right. Make sure these 2 points are coinciding. So one more light ray. See, this is another light ray. Closely if you observe, you can see neatly. This is one more light ray. After reflection, it is passing or retracing the path. So now if you look at these two reflected light rays, these two reflected light rays are not meeting. They will not meet anywhere because they are looking like diverging light rays. That's why what we are going to do, we are going to extend the light rays back side. See, this light ray I'll extend back. I'll keep the scale along the reflected light ray and I'll extend the light ray back. And this light ray also, I'll keep the scale along the light ray and I will extend back. See, where did those both light rays meet? They both light rays met here. This point will be mentioned as image I. If you look at the question, they asked you to draw the labeling. If sometimes they'll ask you to draw the labeled diagram. What labelings can we give here? We can give the labelings as this one. From here to here, from focus to pole, this will be focal length. And from pole to image, this will be image distance. And from pole to object distance, this one will be object distance. What labelings? If they ask you to draw a labeled ray diagram, then this one will be V, that is equal to plus 24 centimeters. This one will be F is equal to minus 12 centimeters. This one will be U. U is equal to minus, it was 8 centimeters. So this much labeling, if we are able to do, then we are not going to lose any mark. One more thing, we can write it as aperture A and A dash. So this is the perfect way of drawing ray diagrams of a concave mirror. Thank you. We'll meet in the next video. If anyone is interested to join our online tuitions, you can join.